Hello, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're looking at Math 1, Worksheet 4.2. Remember that every problem on this homework help mirrors the problem on your homework. So if you have a problem with a particular item, fast forward to that problem and this should help you figure out how to solve your problem. So let's get started. Problem 1 says to solve each system using substitution. All right. So check your solution when you're done. So in this case, we're looking to see if there's any variable. The first step is always to solve for one of the equations. And notice in this case, we already know x is solved, x equals 5y. So what we're going to do is we're going to take that and plug it in for x. So we'll rewrite this equation 3, and instead of x, I'll put parentheses, and I'll put in the 5y. That's the key. Since x equals 5y, I'm going to put it in for x. And now what I end up with is an equation, you notice, it only has the variable y. When I have one equation and one variable, I can solve that. So let's solve it. First multiply 15y minus y equals 73. And then that's 14y, combined terms, equals 73. So y equals 73 over 14, which is also could be, if you want to put it in a form, y equals 5 and 3/14. Pretty ugly problem, but it's really not that hard. Now the second thing we want to do is we're going to take this answer here. So we know what our y is, and now we need to find our x. And I'm going to go ahead and put it into this equation and find out what x is. So notice that if x equals 5y, then x equals 5 times 73/14. Notice I went back to my fraction instead of the mixed number because you can't multiply a mixed number. I would have had to change it to a fraction anyway. So if I multiply that out, I'm going to get 365 divided by 14, which is 26 and 1/14. All right. So my answer then is, the answer is x is 26 and 1/14, and y is 5 and 3/14. Okay. Now, if I want to test my answer, if I want to do my check, since we used the first equation, we need to use the second and see if we get a true statement. So if I go 3 and then I put in x, which is 365/14, minus 5 and 3/14, or 73/14. What does that equal? Does that equal 73? That's what we're trying to find. Okay, so 3 times 365 is I end up with 1095 minus 73 times 14. And so that minus 73 is 1022 divided by 14. And 1022/14 divided by 73 is indeed 73. And so I know my answer is correct. Whatever equation you use to solve with up here, when I put this back into here, I check with the other equation. So now I have an equation here, and our answer again is right here. All right? Hopefully the next one won't be as nasty. Problem 2, again, we're going to use substitution. Notice that I have an equation that is already solved for y right here. Y equals 4x minus 5. So what I'm going to do is take this y and plug it into the second equation right there. So we're going to write this first equation with the substitution. So we have minus 3x plus 2 times 4x minus 5. Notice I put in parentheses so I don't lose some of the factors, equals 20. So we'll distribute first here. Minus 3x plus 8x minus 10 equals 20. Combine terms here. Minus 3 plus 8 is 5x minus 10 equals 20. Undo the minus 10 by adding 10 to both sides. And we get 5x equals 30, a lot easier than the first problem. Divide both sides by 5 to undo the division here, and we end up with x equals 6. Now we need to find y. So I'm going to use this equation here and realize that y equals 4x, but now I know that x is 6, so 4x minus 5, and that's going to be y equals 24 minus 5, which equals 19. So that means my answer here is x is 6 and y is 19. Now the next part is to check your answer. So we use this equation, so let's check the other equation. So minus 3 times x, x is 6, plus 2 times y, and y is 19. Does that equal 20? Okay, so here we have minus 18 plus, this is going to be 38, and minus 18 plus 38 is indeed 20, and so I know my answer is correct. The answer then is 6, 19. X is 6, y is 19. Solves both of those equations, and therefore is a solution to this. Problem 3 asks us whether the system has one solution, infinitely many solutions, or no solution. Okay? What does that mean? One solution would mean the two lines cross and there's one solution. Infinitely solution means that there's one line and then the other line is the same line on top of it. So every point on one line is on the other line. That's what gives it the infinite look. Okay? So when they're both the same line. The last one is no solution, and that's when you have two lines that are parallel, so they never intersect. Now, when we graph them, we can see that, but when we do it algebraically, you're going to see what happens is we're going to end up with either an identity or a contradiction or an answer. So in the first case here, let's begin the substitution process, and notice here that I have y equals 3x plus 1, so I'm going to put that into the y equation. All right, so we write the second equation, 6x minus 2 times 3x plus 1 equals 6. All right, so let's distribute here. And we get 6x minus 6x, and then minus 2 equals 6. These two go to 0, 6x minus 6x, so I'm left with minus 2 equals 6. Well, that's never true. All right? Never true. So what can I say about how many solutions there are? There is no solution. If you were to break these down into slope-intercept form, you would find that they both have a slope of 3. In other words, these must be parallel lines. And just to show you that, let me solve this one for y. So if I add 2y to both sides, I get 6x equals 2y plus 6. If I subtract 6, I get 6x minus 6 equals 2y. And so if we divide by 2, notice that I get 3x minus 3 equals y. Or, flip it around, we say y equals 3x minus 3. And you notice the slope is 3, just like it is on the first equation. The only difference is this one has an intercept of minus 3, and this is 1. So again, we're dealing with parallel lines. But algebraically, that showed up because we ended up with something that was not true. Minus 2 equals minus 6. Never true, and so there'll never be a solution. Problem 4 is like problem 3. They want to know, is it one solution? Do the lines cross? Infinite solutions? Are they the same line? One line right on top of the other line? Or no solution, are they parallel? Okay. Now this time, this one's kind of an interesting problem because it isn't solved for y, but I noticed one thing interesting. Notice that this equals 1 over 2y, and up in this one is a 1/2 y. Those are the same thing. So what I'm going to do is take this number that equals that and put it in for there. There's no reason to solve all that for x or y when this equals that, so I'm just going to substitute it in there. Kind of a tricky little question. So I write the first equation again and then substitute in. Minus 2x plus, and then we have 2x plus 12 equals 17. Now notice minus 2x and 2x goes to 0, so I end up with 12 equals 17. When is that true? Never true. So what's that mean? There is no solution. Or again, we could say they're parallel lines, but there's no solution for this equation. Problem 5 is about a talent show. It says in our talent show we have singing and comedy acts. Singing acts are 10 minutes long, and comedy acts are 5 minutes long. The show has 14 acts, and it lasts 90 minutes. How many singing acts and comedy acts do they have? Well, there's two things we have. We can write two equations for this. First of all, how many acts do we have? Well, we have 14. Well, I'm going to let x be the number of singing acts and y be the number of comedy acts. Okay? So the number of acts, x plus y, add up to 14. The next equation is how long do they take? How much is the time of the acts? Well, every singing act takes 10 minutes, so 10 times x. In other words, if I have two singers, it takes 20 minutes, 3 would take 30. Whatever x is times 10. Likewise, the comedy are 5 minutes, so 5 minutes times y. And all of that adds up in a constraint in our problem as 90. All right? So there's our two equations. Now to do the substitution is pretty simple. I can change these if x plus y equals 14, then I know that x equals 14 minus y. So this is what I am going to substitute then in for x and work our problem. So we have 10 times x, and now I'm going to put in here 14 minus y plus 5y equals 90. So let's distribute here. We have 140 minus 10y plus 5y equals 90. Combine terms here. 140 minus 5y equals 90. So let's undo the plus 40 by subtracting 140 from both sides. And we get minus 5y equals minus 50. Divide by negative 5. And we end up finding out that y equals 10. So there are 10 comedy acts. Well, if there's 10 comedy acts, that implies that x, which is 14 minus y, is 14 minus 10, which means there are 4 of those. Okay? So our answer is there's going to be 4 singing acts and 10 comedy acts. Now, if I want to do a quick check, notice I use that first equation. 10 singing acts times 4 plus 5 times, there were 10 comedy acts. Notice that that's 40 plus 50, and sure enough, that adds up to 90 minutes. So I know that this is my correct answer here. Problem 6, when is the substitution method better than graphing for solving a simple system of linear equations? Well, the problem here is that graphing can be inexact. All right? And it can be difficult to read the exact point. A lot of the problems we've done in class have been fairly simple and end up really nice integers. But if you have a solution that's non-integer, this isn't going to work. And in that case, the substitution method is better because it can give you an exact answer. Because it always gives you an exact answer. All right? For the next two problems, they say, for each system, tell whether which equation you would use first to solve for a variable in the first step of the substitution, then explain your choice. Notice they're not asking you to solve this, they just want to know where would you start at. And what you have to think about is as you look at these factors here, recognize that if you solve for any of them, if you solve for minus 3x or 5x or 4x, after you get them, you're still going to have to divide by the coefficient. So what you're looking for is there any variable that that has a coefficient of 1 or minus 1? And notice there, that's the one there that, notice if I take this equation here, in one step, just by adding the 3x to both sides, I've solved for y. Okay? So this is the equation that I would solve for first. I would solve for y because I only have to do one step, and now I'm ready to substitute that into this equation. Notice that, for example, take that one there. If I tried to solve for x, for example, I could go, okay, minus 3x equals minus y minus 2, move the y, and then I'd have to divide by minus 3, and I could get it, and I would have minus 1/3 y plus 2/3. But notice it took me 2 steps to get there, whereas here it only took me 1 step. So that's why that's the easier way to do it. Number 8 again asks us to figure out which is the simplest way to solve for one variable. Again, I'm looking for an x or a y that either has a 1 or a minus 1, because then I won't have to divide out the coefficient. So you notice here I have a 3.5x, a minus 8x, a 7x, but right here I have a minus y. All right, so that's what I'm going to look for, and because that'll be the easiest way to solve for it. So for example, if I have 7x minus y equals 2, all right, let me do this. Let me get rid of the 7x, and I get minus y equals minus 7x plus 2, and it doesn't take much to go, oh, I'm just going to multiply that by negative 1, and I get y equals 7x minus 2. Now, granted, it did take one step and a second step to multiply, but multiplying by negative 1 is not the same as dividing by a number and having fractions. It was just reflecting on that. So that would be the simplest way, is to take the second equation, to use the second equation to solve first in solving this substitution. Problem 9 says, when solving a system using substitution, if you obtain an identity, then the solution has no solution. Well, this is absolutely false. For one thing, if you have an identity, for example, like 2 equals 2, when does 2 equal 2? All the time. So as a result, when you get an identity, this implies infinite solutions. Infinitely many solutions. When you're solving a system, it usually means the two lines are actually the same line and has infinite solutions. Problem 10 asks whether it's true or false. You cannot use substitution to solve a system that does not have a variable with a coefficient of 1 or not. That's absolutely untrue. Let me show you an example. If I had this equals 5 and let's say 4x minus 2y equals 10, I could decide any one of these to solve for. For example, if I took this and decided to solve it by x, it's true that when I move the y over here, I didn't do it in one step. I would then have to divide by 4 to get x equals 1/2 y minus, what is that? 5/2. So I had to do 2 steps. I had to divide. It may be a little messier, but it can be done. By the way, this is the kind of problem that we're going to use the other method, elimination, when we move on to the next unit. But this is false. You can use substitution on any set system of equation. Problem 11 is interesting because what the student did is they took this equation here and notice they solved it for, all right, they solved it for x. So they took x plus 8y equals 21, and they solved it for x, subtracting 8y from both sides, and they got x equals 21 minus 8y, and that's absolutely correct. Okay, so this is okay. But here's where they made a mistake. Because they were using this equation, they took this and put it back into the same equation they took it from. You don't do that. What you're supposed to do is take it and put it in the other equation. So I would take 7x plus 5y equals 14, and I would plug the x in there. So I have 7 times 21 minus 8y plus 5y equals 14. So when I distribute here, I'm going to have 147 minus 56y plus 5y equals 14. Combine our like terms here. 147 minus 51y equals 14. So we're going to subtract 147 from both sides. And we're going to get minus 51y equals negative 133. If we divide by negative 51, we get that y equals negative 133. 51, pretty ugly problem. But that is going to be 2 plus 3151, right? So now if I plug that back into my original equation here, x equals 21 minus 8y, we see that this is going to be x equals 21 minus 8 times 133 over 51. So x is going to equal 21 minus 1064 over 51, which ends up equaling 751. And so our final answer then is going to be 751x and 2 and 3151y. Pretty ugly answer. The key thing to notice here was the mistake. He solved this problem for that and then put it back in the same thing. That's why he got an identity. You need to take whatever one you solve from. If you use this one to simplify, you make sure then it goes into this one. That's the substitution. You don't substitute it back into the same equation. All right, so I hope you do well on your homework and see you in class again.